notes on 6-6, solving log equations. Log equations, they might have log or they might have natural log, but all of the rules, the power rule, the quotient rule, the power rule, they all work the same. So don't be worried if it says natural log. What's the base for natural log? E. Yeah. So this is like saying log. I could rewrite this as log base E, but you're never going to see that. So here are the tips. So if both sides, let's just say match, like you have natural log of something equals natural log of something, or log, then you can sort of effectively cancel the natural logs. Really what you're doing is you're exponentiating both sides and you're doing e raised to the power. So you're going like this, e raised to that power and e raised to that power. That's really what you're doing. And then since we've talked about this many times, they're inverse operations. So natural log and e raised to a power are inverse operations. So really that's what's canceling. And this is a very, very easy equation to solve. It's just 7x minus 4 equals 2x plus 11. So the tip that I want you to write down is there's 3 different types of log equations. When both sides match, the logs cancel. And then, of course, once we get to this part, it's just a matter of getting the x's on the same side. So I would subtract 2x from each side. 5x minus 4 equals 11. And then I would add 4. It's all very relaxing, meditative, easy algebra. And then we get x equals 3. And you can actually, on like a quiz, you can plug 3 back into each side and just make sure you did it right. Okay, now this one throws people off. Log base 2 of x minus 6 equals 5. People get stuck, have no idea what to do. The thing you need to remember is simply rewrite it in exponential form, which we practiced when we started this chapter. We did a whole page of doing this from the early on. So you take the base, right? It's like you go in this order. This is the base 2. The exponent is here and the answer is here. So 2 is the base, 5 is the exponent, this is the answer. So it goes like this. And 2, right, base raised to the 5th power equals the answer. What disappeared when I did that? The word, the log function totally disappears when you write it in exponential form. That's why that's what you want to do. Because otherwise you're not going to be able to solve for x. So now it's a very simple 2 to the 5th power is 32. You could use your calculator if you have to. Add 6 to each side. And 38 is what will work there. Okay, number 3. And then the last type of equation is, okay, this we haven't seen before, but we did practice condensing. We took expressions and condensed them into one, and that's what you have to do first here, because otherwise we're not going to be able to solve it. So remember the law. I'll write it off to the side here. Log, what was log A plus log B is equal to log AB, exactly. So you can condense it into one expression. So it's log 5x times x minus 1 equals 2. That's the hardest step. So I use the law of logs to take log A plus log B and rewrite it as log AB. Now it's a little bit easier. Now I do the same thing I did in the last problem. I write it in exponential form. What's the invisible base here? Yeah, so let's write in a little base 10 just to be sure you know that's there. When you just see log, it's automatically base 10. So now we can write it in exponential form. So the base 10 raised to the 2nd power, that's the exponent, equals the answer. And this one is going to take a little bit longer to solve because when we simplify it, we get 100. We have to use the distributive property, 5x squared minus 5x. And so what kind of equation is this? Quadratic. So we get to review solving quadratic equations. You always have to get them equal to 0 first for quadratic. And then we factor. And what's the first thing that you do when you factor? You look for a common factor, which is 5. So let's take that 5 out to make our lives easier. It really does make this easier. And then, we can do a basic diamond problem. What multiplies to negative 20 and adds to negative 1? And that is 4 and 5, 4 and negative 5. So we get x plus 4, x minus 5. And so we get x equals negative 4 or 5. Now, we have to check for extraneous solutions. When you solve log equations, check. This is like when you solve radical equations. It's called extraneous. You do have to check. And if I plug, you can't take the log of a negative number. It's not. So if you plug negative 4 in here, you're going to get negative 20 times negative 5. That'll actually give you, that one might work. Let's see. If you take log, let's try negative 4. So you do log of, you get log of negative 20 times negative 5. That one might work. Log of 100 equals 2. Okay, so the negative 4 works when I plug it in. The 5, is that going to work? Log of 25 times 4. It looks like that's also going to work. So we're okay. Oh, I know why. I'm sorry. You know why it doesn't work? Because you have to look at the original equation. And if you plug in negative 4 in the original equation. Okay, so good learning here. You have to plug it into the original equation and it has to work, and it doesn't. So you're not going to be able to take the log of negative 20. You're not going to be able to raise 10 to a power and get a negative answer. So that does not work, and 5 is your only solution. You've got to check for extraneous solutions. So let's try one more together. So these are a log base 4. That's not a problem. We can use the law of logs to combine them. Log base 4 of x times x plus 12 equals 3. And then what do we do next? To get rid of the log, we write in. It's exponential form. So the base 4 raised to the 3 power equals x times x plus 12. So 4 cubed. 4 times 4 is 16 times 4 is 64. Nice. We got to distribute this. X squared plus 12x. And so if I write it all on the left side, if I just flip this, I would get equal to 0. If I get it all together on the same side. And this is a nice, easy diamond problem. What multiplies to negative 64 and adds to 12? And if we're not sure, we can just list. Okay, 64 is, what do you think it is? 16 and negative 4. Thank you. So x plus 16, x minus 4. So you get x equals negative 16 and 4, and we do need to double check. And sure enough, if we plug negative 16 in here, we're going to be taking the log of a negative number, and it's not going to work. So our only answer is 4.